If I ask you how do you create and manage Kubernetes clusters, you're likely going to give me one of the two answers. Either you are using managed Kubernetes clusters like GKE, EKS, AKS, and so on and so forth, or you're setting them up yourself. Managed Kubernetes clusters are great, but they can be expensive. They can be really expensive. Actually, now we might argue whether that's worth it or no, but I will leave that for a different video. If you're managing them yourself, then that can be tedious. You need to create servers, virtual servers, bare metal servers, any type of servers. You need to install an operating system on those servers, and then you take kubeadm and start figuring out how to install Kubernetes on those servers, how to connect all those servers, how to set up networking, how to do whatever else you might need to do. You might simplify your lives with K0s or K3s, but they still need an operating system. So you're not removing any of those layers. You're just potentially simplifying the last part of installing or managing Kubernetes clusters. What I would like to explore in this video is how can we get somewhere in between of those two extremes of managed Kubernetes clusters or self-managed Kubernetes clusters with tools like kubeadm. When self-managed Kubernetes clusters are concerned, what we really need is a Linux operating system distribution that is designed specifically for Kubernetes. And Talos might be just the solution we're looking for. It is secure from the get-go because all the access to the cluster is through the API. We cannot do SSH or any of those things that we might be used to doing in the past, but we shouldn't be doing today. It is predictable because it eliminates configuration drift, it reduces unknown factors by having immutable infrastructure layer on top of our servers, and it delivers atomic updates. It helps with what Talos calls evolvability. It simplifies the architecture, it increases the agility, and it always gives us a stable Kubernetes and Linux distribution. Now you might be asking, hey, where does it work on? Where can I use Talos? And the answer is almost everywhere. If you're using bare metal platforms or servers, it works with Digital Raver, Equinix Metal, Matchbox, and Sidera. If you use virtualized platforms or virtual servers, you can run it on Hyper-V, on KVM, or Proxmox, on VMware, and on Xen. If you prefer cloud, it supports AWS, Azure, DigitalOcean, Google Cloud, Hetzner, NoCloud, OpenStack, Scaleway, UpCloud, and Vultr. And finally, it can run on your laptop as well through Docker or Kemu or VirtualBox. So when I say everywhere, it's almost literally everywhere. And since it is open source, we can expect the number of platforms, the destination platforms, to increase, and you can contribute yourself. Nevertheless, if you're using something that is not on this list, then you might think twice whether you should be using that platform in the first place. Okay, so let's see it in action. But wait, sorry, stop. Before we go into a demo, I need to give a huge thanks to Alfadil. He's the one that introduced me to Talos. He's the one who helped with the scripts, with the demo that I'm going to show. He wrote the notes. His help was absolutely crucial. This is more his video than mine. He's an SRE at A&B, and he's absolutely awesome. Thank you so much for helping with this video. And if you would like to help with one of the future videos, just let me know. I really appreciate it. Now let's go into the demo. Now for the demo, I will be using DigitalOcean, not DigitalOcean Kubernetes, just DigitalOcean because, hey, I need servers to run my cluster. But do not be concerned because, as I said before, it works almost everywhere. I just had to pick a platform, and I already created an external load balancer, and I already created an image based on Talos. So those two things I did in advance. I did not want to bore you with all those details, and as always, all the instructions, both those that I executed before I started recording this demo and what I'm about to do now, are in a gist, and the link to the gist is in the description so you can follow along. Anyways, I have a load balancer and I have images already stored in my DigitalOcean account. And the first step, actually not the first step, the first step I will show you is to generate configuration that Talos will use to do whatever it needs to do. So I'm going to generate config called Talos demo. It will contain the URL, the IP actually of my load balancer, and I will specify that I want Kubernetes version 1.23.0. That generated 3 files. One, control plane YAML, describes the control plane of my cluster. The other one is worker YAML that describes the worker nodes of the cluster. And the last one is Talos config, which is configuration itself of Talos, what Talos needs to create and manage the cluster for me. I will not go into details of all those 3. They're rather huge, they're massive, and it will take a lot of time to go through all the options. You can explore them yourself. I want to go through the happy path right now. And the next thing I will do is create 2 environment variables that will contain information about the size of the nodes that I want to create and manage with Talos. One is control size and the other one is worker size. They're both set to S2V CPU and 4 GB, which is basically servers with 2 CPUs and 4 GB of memory. And then I will go through a small loop that will create 3 VMs that will act as control plane nodes and 3 VMs that will act as worker nodes. There is nothing really special. This is DigitalOcean command, nothing to do with Talos, except that I'm using a specific image. That's the image that contains Talos operating system that already has Kubernetes baked in. So that's the only special thing. The rest is just DigitalOcean stuff, and your commands will be different depending on the platform you're using, but the logic is still the same. We are going to create worker nodes and control plane nodes based on specific image. And that's about it. We're not doing anything else but creating nodes with an operating system, which just happens to be Talos. Now I have my nodes up and running, or they will be up and running in a couple of moments because DigitalOcean is extremely fast, and I can jump into bootstrapping Kubernetes inside those nodes. To bootstrap my Kubernetes cluster, I need to figure out the IPs of all the nodes I have in my cluster, so I will execute another loop that will go and execute commands in DigitalOcean that will get the IPs of control plane nodes and of the worker nodes. And there's not much mystery there, so let's move on. Actually, what I said and what I did is wrong. I do not need IPs of all the nodes. I need IP of one of the nodes, one of the control plane nodes, but nevertheless, I already have all of them, so that should be fine. And I'm going to execute Talos Cattle, and then Talos config is the one that I generated initially, and I want to configure the endpoint with the IP of one of the control plane nodes. And I'm going to do the same thing again, except that this time I'm going to configure the node with one of those IPs. And now that Talos knows how to find one of the servers, all I have to do is execute Talos Cattle, pass in the config, and then bootstrap the cluster. And Talos will do everything that needs to be done to make sure that all those nodes, not only that one node with that IP, but all the nodes are working correctly and that they're living happily ever after and all the jazz that we want with Kubernetes. Now, since I'm paranoid, I need to double check whether all this really works. And I'm going to do that by executing yet another Talos Cattle command that will retrieve kubeconfig and store it in a file on my laptop. And then I can use that same config to execute any kubectl command. Like, for example, I will retrieve all the nodes with kubectl, and then kubeconfig is whatever the file is, and then get nodes. And the output shows that there are no resources found. This is disappointing, right? It's a big failure. But actually, this is no reason to panic. I was just too hasty. I was too fast. Talos might need a few more moments to set up everything, to configure the whole cluster. So let's wait for a couple of seconds and try it again. And while we're waiting, I should let you know that you should really subscribe to this channel. And if you reach this far into the video, you should say that you like it. And if you want to support the channel, you might consider joining the channel. It's the price of a coffee, and that helps a lot. So let's retrieve the nodes one more time, and now you can see that one of the nodes is there. It's a worker node, it's not yet ready. And if you do it again, then we can see that we have 2 control plane nodes and 2 worker nodes, and then we retrieve the nodes again, and there is additional worker node. And then if you do get nodes, one more time, we can see that all 6 servers, no, this is 6 servers, are up and running. 3 of them are control planes and 3 of them are worker nodes. They're not yet ready, but they will be soon. They're just coming in. So let's do it one more time. They're getting ready. Not all of them are ready. And then let's repeat. Then now most of them are ready. And let's do it one more time. Now they're all ready. My cluster is up and running. This is amazing. I mean, this is not amazing. This is how it should be. They are all ready. My cluster is fully operational. Rejoice. Now, arguably, you could do something similar with other tools. Most of them are not giving you a combination of operating system and Kubernetes packaged together, but you could do something very, very similar. So that might lead you to think that there is nothing really special about Talos, but there is. So let's talk about what makes Talos really special beyond being a combination of operating system and Kubernetes baked together into an image. Talos is very, very secure for 2 reasons. To begin with, it is a very, very, very minimalistic operating system that doesn't have anything that you don't absolutely have to have. So the smaller surface of attack, the smaller the distribution, the more secure it is in general. But that is not all. What makes it really, really, really secure is that you cannot change anything on those servers. You cannot SSH into a cluster and do random hocus pocus stuff because that is simply not allowed. The only thing you can do is communicate with Talos through its API, and I can prove it to you. Let's execute do cutl compute SSH and then let's say Talos demo CP2. Let's say second control plane node. Now I'm using DigitalOcean here only because it's easier to try to SSH using DigitalOcean, but any SSH should produce similar outcome. And the outcome is, well, connection was refused. There is no SSH. You cannot SSH into something that doesn't have SSH into there. You cannot enter into any of those servers. You cannot mess it up simply because you're not allowed to mess it up. You have to speak with the API and do only the things that are allowed to be done. The second big selling point is predictability, and I can demonstrate that by adding a node to the cluster or removing a node to the cluster. We know exactly what will happen because that's what it was designed to do. We can do very few operations and they're working really, really, really well. They're predictable and we know exactly what will happen. So I can create a new node. I just create a new node. I'm not going to do anything Kubernetes, this and that. I'm just going to create a new node based on the same image and I'm going to call it Talos Demo Worker 4. Now, I'm not telling it how to connect to Kubernetes cluster. I'm not doing anything except create a new node. That's important, remember, because let's see what will be the effect of that. And we can see the effect by retrieving all the nodes with kubectl, kubeconfig, etc., get nodes. And at the beginning, it's nothing. There are still 6 nodes. So let's wait for a couple of moments and repeat that command. Still nothing, second time still nothing. Let's see the third time is a charm, and there we go. Right, we have the 7th node, 4th worker node joining the cluster just by creating a node, just by creating a virtual machine based on that image. It's intelligent enough to figure out that it should join the cluster because that's what it's for. Similarly, I can delete one of the nodes. I can simulate failure of a node by deleting that node. So let's see what will happen if I do just that. So let's do it one more time, get nodes, and this time we can see that the new node, no, it's actually not new node. We can see that the old node was removed and now it is set as not ready. Talos will not remove it completely from the cluster. We need to execute kubectl delete node command, but it is aware that it is now ready. We saw that we can add nodes and they will automatically join the cluster, and we can remove nodes and Kubernetes will figure out that they are not ready and stop using them. And the last big selling point for Talos is what they call evolvability. Or let's simplify it, let's say operations. Like we can do things that we need to do without cluster, like for example, upgrade Kubernetes by executing Talos cutl and then pass the config and say upgrade K8s and specify to which version we would like to upgrade. I'm going to run it first with dry run and see what we'll get, and then we're going to upgrade it for real. This takes a while, and it tells us essentially what will happen if we would run the same command without dry run. So let's move on and remove dry run and do it for real. So let me execute the same thing again. Talos cattle upgrade Kates to 123.1 without dry run, and then wait, and we can see it progressing. To begin with, it is updating the node, and updating nodes or upgrading nodes in Talos means something different than in many other operating systems. It is preparing the server to upgrade. It is immutable, so it will not upgrade the server directly at runtime. It is downloading new image, and potentially later on it will start preparing that new image to become the operating system. So it will just switch from the old to the new version instead of upgrading it at runtime. It's immutable, and that's absolutely amazing. So let's fast forward to the end of the process and see what will happen. It failed. And you might say, hey, why did it fail? But it makes sense for it to fail, because remember, I removed one of the nodes. I physically destroyed one of the servers. So one of the nodes is not ready. So it couldn't upgrade the whole cluster because there's something wrong, right? And we shouldn't be upgrading the cluster when there is something wrong. So Kubernetes and Talos do not know that I intentionally removed the server. So I should first tell Kubernetes, that cluster, that server should be deleted instead of just failing, because for all we know, it might recuperate, right? So let me remove the node first and then repeat the upgrade command. What you will notice in this second upgrade, after I remove the node, is that the things go much faster because it already updated its own images. So it already has everything it needs to have. It just needs to switch to the new Kubernetes version. Actually, it's not only that, but there are a few things involved. But what does matter is that the images are already updated. Some things are already configured. So it is not starting from scratch. It is ready. Let's put it this way. It is ready to do rolling updates or rolling upgrade of the cluster. Now, while the upgrade is happening, you should know one thing, and that's that it is doing what I already mentioned, rolling upgrades. So it is upgrading one node at a time and checking what's going on and so on and so forth. So it is not just going to upgrade the whole cluster at once. That would be disaster. You should never do that. It is upgrading one node at a time. You don't see this here. I should have opened the new terminal. I didn't. Anyways, you need to trust me that it is performing rolling upgrades. And now let's fast forward to the end of the process. There we are. And now I can retrieve all the nodes just as before, and the output is almost the same. The major difference is that if you focus on the version column, you can see that now all the nodes are version 1.23.1. Now let's talk about the things that are missing. What is missing in Talos that you might need, or is there anything missing? By the nature of managing Kubernetes cluster yourself and the provider, in this case Talos, not knowing really what are all the pieces that you might need, some things are missing, and some things, actually nothing is really missing. It's just that you need to do some fine-tuning yourself, and that would happen probably with any self-managed Kubernetes cluster, and Talos is not an exception. For example, there is no load balancer, or to be more precise, there is no ingress. There is a load balancer, but there is no ingress. And we can prove that by listing all the services in all the namespaces, and we can see that there are only the default services, you know, those that come out of the box, but there is no ingress. You will need to install it yourself. I think that there is a helper command in Talos. I'm not 100% sure. In any case, you need to install ingress yourself and choose whichever one you want, like Nginx or Traffic or whatever you want. The same thing can be said for storage classes. Your cluster does not have storage classes. You cannot mount volumes, mount directories or disk drives or whatever you're mounting into your pods, into your containers. And I can prove that as well by listing all the storage classes, and you can see that there is none, right? You need to add storage classes. Those are the two most important things. You need to install Ingress, assuming that you're using Ingress. Maybe Service Mesh will give you Ingress as well, depending again on what you're using. You need to set up storage classes yourself. And there could be many other potential things that you need to add, but at least you got a fully operational Kubernetes cluster, if you could say that it is operational without the storage class. But that's the game, that's the disadvantage of managing cluster yourself. If you would run it as EKS cluster, GKE or AKS, you would get those and many other things out of the box. You don't get with Talos, simply because it assumes that you will make choices yourself about the layers on top of core Kubernetes. Remember, storage classes are not part of Kubernetes, they're installed separately. Now, there could be many other things that you might be missing depending on what you really need, but as I said before, you got a base Kubernetes cluster that is easy to manage, easy to upgrade, easy to do whatever. It is immutable, it is secure, and so on and so forth. There are many other things you can do with Talos. I do not have time to go through all of them, so you just check it out. You can execute Talos Cuttle help, and you can see all the things that you can do. Whether you'll do them or whether you will use them or not, that's up to you. Now let's talk about pros and cons. Is Talos something you should be using or no? Let's talk about it. To begin with, it makes no sense for you to use Talos if you chose to use managed Kubernetes services like those that I mentioned before. It could be AKS in Azure or EKS in AWS or GKE in Google Cloud or Alibaba or DigitalOcean. The provider that I used gives me managed Kubernetes cluster, and it's absolutely awesome because it reduces the amount of work I need to invest into creating and managing Kubernetes clusters, but it costs extra money. Now, if you don't want that, if you want to manage it yourself fully, then Talos is a very good solution. It kind of competes, but it doesn't compete with other solutions. You could be using Cluster API. By the way, there is a video about Cluster API or K0s or K3s, etc., etc. They're all also great or not, depending on how you look at it. But there are a few things that makes Talos special. And to begin with, none of those that I mentioned have an OS baked in, or to be more precise, Kubernetes baked into OS. What makes Talos special and different from most, not all, but most of the competing products is that it is an operating system with Kubernetes baked in. What else? Yes, it's very easy to create Kubernetes clusters on almost any platform, and it is easy to operate Kubernetes clusters. It is minimal. It has just enough, just the things you need and nothing else, which is great because that makes it secure. I'm going to get to security. Now let's move into immutability. It is immutable. If our containers, if our applications running in containers are immutable, then why not have everything else immutable? And that applies to operating systems and VMs and so on and so forth. And Talos, even though I didn't go into depth, is immutable. Its file system is read-only. There is no shell. There is no SSH. You can communicate with it only through the API, and the operations you're doing are done in an immutable fashion. What else? Oh yeah, it's ephemeral. The whole Talos OS runs in memory. That's what makes it fast, that's what makes it easy to upgrade, easy to switch from one version to another, immutable, remember? And since it is very small, very minimalistic, being ephemeral, running in memory is doable and very beneficial. It is secure by design. The API is the only access point, and that makes it, together with immutability and together with being minimalistic, very secure. And by the way, I did not mention, I should have, it is also secured through MTLS or mutual TLS. And finally, the last big positive thing is that it supports almost any platform. It runs in bare metal, virtualized, cloud, local platforms, and each of them, in each of those categories, supports a bunch of providers. So that's really awesome. You can run it almost anywhere. Now, there must be some negative things as well, right? Not everything can be great, and indeed, not everything is great. To begin with, documentation is not good. There are examples, there are quite a few examples, but if you want to find out what all those things mean and how to do it and what to do, if you want to go in depth, documentation has a lot of things left to be desired. And that, together with few other things, makes learning curve very steep, right? It's mostly due to lack of documentation, a few other things. So be prepared that you will set up, actually, you will create the cluster very fast, very easily. But then when you go into details, that might take a lot of time. And finally, one of the pros is actually con as well. I already said that having only API access to the cluster, to the servers, is a great thing because it makes it more secure and so on and so forth. That's also a negative thing, because as long as that is working, that's absolutely amazing. But if things go wrong, you will be in a complicated situation because not everything can be fixed through the API. And now I'm confused. I'm not sure. I really like the idea of not having SSH access. That makes implementation best practices much more compelling. You're forced to do it. That makes it more secure and so on and so forth. But when things go wrong, you might actually want to have that SSH access. Overall, I think it's absolutely amazing. And if you do want to manage Kubernetes clusters yourself, then Talos is a great choice. I am not saying under any circumstance that we should not be using managed Kubernetes clusters, EKS, AKS, GK, and so on and so forth. But if you did choose to manage it yourself, then Talos is a great choice. Give it a try.